One more example. We're going to make this one a little bit more interesting. F is going to go from the integers across the integers, and it is going to be sent to the integers. So in order to do the next line, think about what I have to take as input. Inputs come from the integers cross the integers. That means that inputs look like ordered pairs, A comma B. I could do X comma Y, I'll do A comma B in this case. Integers have to look like ordered pairs. I can send these to anything I want because I'm making up this function. This is my rule. So I'm going to send these to 3A plus 6B. I could make up that rule in any way I wanted to. This is how I'm choosing to do it. Domain should be easy. That's the integers cross the integers. All good. The codomain should also be easy. That's just the integers. No problem there. Domain and codomain. Range is going to be really hard to find for this one. So we are going to stop with finding range. And what I want to do is just write out a couple of ordered pairs. So let's do f of 1 comma 2. It should be equal to 3 times 1 plus 6 times 2, which is 9. So therefore, if I write f as a set of ordered pairs, my first component would be the ordered pair 1 comma 2. That's totally not equal to 9. Oh my goodness. My first component would be the set, the ordered pair 1 comma 2. Let's try 15 in this case instead of 9. And my second element component would be 15. Sorry, it's Friday. Do we see why f of 1 comma 2 is equal to 15 now that I'm doing my arithmetic correctly? Okay, one more. F of negative 3 comma 4 is 3 times negative 3 plus 6 times 4. That should be also 15. I didn't do that on purpose, but okay. So we could also say that negative 3 comma 4 and then comma 15 is in my ordered pairs set as well. Negative 3 comma 4, 15. I am going to need to do dot, dot, dot. This is nowhere close to all of the elements in F. It is totally not all of the elements in F. It's just a couple of them. But in this case, my first component is an ordered pair, and then my second component is an integer. First component is an ordered pair, second component is an integer. Range is going to be hard to find in this case, so we are going to leave range off until we have some more tools to deal with that. All good? Make sense on this example? Give me a thumbs up or nod. Yes, we're good, we're happy. Okay, a couple more definitions and then we will be done for today. So, definitions. If little f of A equals B, A is what's called the pre-image, and B is what's called the image. So I've been saying input and output. The technical math terms are pre-image and image. That's the technical math terms. Untechnical, input and output. Technical, pre-image and image. Technical math terms here. So pre-images always live in the domain. Images always live in the codomain, and they also live in the range. So pre-images are always elements of or live in the domain. Images always live in the codomain. And then because f of A is equal to B, this is an actual output, it also lives in the range. This is an actual output. Last thing, what I asked you on your reading assignment. Two functions are equal. So we'll say two functions, f and g, are equal. if f of x equals g of x for all x living in the domain. I'm making the assumption here that f and g have the same domain. So two functions f and g are equal if f of x equals g of x for all x in the domain. And the example that I gave you on your reading assignment, you guys did well with telling me why the functions were not equal. So for example, if f of x is equal to x and g of x is equal to the absolute value of x, then we can say that f and g are not equal because I got some good counterexamples. F of 5 equals 5. Sorry, negative 5. F of negative 5 equals negative 5, but g of negative 5 is the absolute value of negative 5, which is 5. So there's just one example. There's a whole bunch of other ones here. So we've got f and g not being equal. I don't feel the need to go over this any further because it was good in the reading assignment. I think you guys got it there. So, okay, that is the quick, fast, virtual, sorry, we don't get to discuss this more like we would in class, introduction to functions. How are we feeling about a quick, fast, virtual, non-discussive, sorry, introduction to functions? How are we doing? Good? Okay. Next time on Monday, we're going to talk about special properties that functions have, and these are these fancy words: injective, surjective, bijective. So that's Monday. We're going to talk about some fancy functions, and then we're going to get back into proofs. So we are going to do proofs with functions. I'll send out a reading assignment. I will send out homework. Remember that your chapter 9 and chapter 10 homework is due on Monday by noon. If you get it done earlier, that's great, but by noon on Monday. Last call. Anything else before I let you guys go? Okay. Have a good weekend. See you guys on Monday. Bye, guys.